Hello, this is Mr. Prickett. I'm just going to go over a quick discussion about probability. The probability basically is just an attempt to predict what might happen, whether it's a game of chance or anything that might have one or more outcome. Now, an outcome basically is a possible result that you can get, whether it's rolling a die or choosing a card. There's going to be a particular outcome, whether it's a number or a certain type of card or whatnot. And an event is the particular condition that you're looking for. For example, maybe you're looking at drawing a king, or maybe you're looking at rolling snake eyes, or something like that. And that's what we call an event. And just a couple of definitions. Probability is, we use the symbol P to represent probability, and of a particular event, A, we'll say, is the probability of that actually happening. The probability of it not happening, we use a symbol called what we call prime. It's basically like a dash or almost like an apostrophe, but we call it A prime, which basically means that event doesn't occur. It's like the opposite. And of course, you imagine the probability ranges from never happening, which is 0%, to always happening. So if you're thinking of it in terms of a percentage, 0 to 100%. If you're thinking of it in terms of a decimal, it would run from 0 to 1. Now, there's three types of probability: empirical or experimental. We've looked at that already. That's something where you can measure based on actually doing the experiment or rolling the die 100 times or whatnot. And it's based on what you get in terms of your data and what you record. Where the theoretical probability is actually based on the mathematical analysis of all possible outcomes. And those two, as we've discovered, can be different. They also approach each other as you increase the number of trials. And of course, in the symbols we use, is N represents the number of either favorable outcomes, or N being the number of trials, N of a certain event, A or S being basically all the total number of possible outcomes. And if subjective is basically something that you might have a sense of from other information. For example, you've got a hunch that your favorite football team is going to win the game because you heard that the running back's injured, for example. That's subjective probability. So event A prime, remember, is that when something A doesn't happen, is also known as the complement of event A. So the probability of event A plus the probability of the event A prime is 100%. Basically either you win or you don't. So if you win 35 times, that means you lost 65% of the time. Also, you can think of it as the sum of both winning and not winning would give you the total number of times you tried the game, for example, or rolled the die. If you're talking about a game of chance. So what is the probability of choosing a king out of a deck? Well, you probably realize there's 4 kings because there's 4 suits. So you can look at it a couple of ways, but we'll just think of it as a deck as a whole. And if you thought 4 over 52 or 1 over 13, you'd be correct. You'd also write that as a decimal or as a percentage of 7.7%. What is the probability of choosing an even number out of a deck? Well, you just have to think about 2, 4, 6, 8, 10. Okay, so that's 20 out of 52, 5 over 13. Again, that's just a simple percentage. And what is the probability of not choosing a face card? So not choosing a face card, you can think of it as A prime. So we'll write it like that. Well, the probability of A prime is 100% minus the probability of event A, which is choosing a face card. So 100% minus the percentage chance of picking a face card would give you the probability of not choosing a face card. And we'll take a look at odds as well. Odds are basically like probabilities, just a different way of expressing the chance of winning or losing. And the odds in favor of an event are different than the odds that are not in favor or against. So how the odds are written and what they are representing is important. The odds in favor of an event A, we basically look at it from the ratio of a probability of the event happening versus the event not happening. So it's a little bit different than thinking in terms of the number of favorable outcomes versus the total number of trials. It's a little bit different. That's for probability. This is we're looking at comparing the actual probabilities in a ratio form. You also can write it as a fraction, and often we do the calculations as a fraction first, and then we can write it as something like 3 to 2 or 2 to 1 odds or something like that that you might have heard of before. And odds against an event happening, event A, would just simply be the reverse or the opposite or reciprocal ratio. So the probability of A prime over the probability of A will give you the odds against. So how the question's asked, whether it's odds in favor or odds against, does make a difference in how you set up the problem. And you can think of it in terms of calculating it in reverse. If you're trying to find the probability in favor, for example, of an event, but by given the odds, we can use this formula, which is the probability of A is equal to H over H plus K. And H over K is really the ratio of the odds of PA to PA prime. And we'll take a look at an example that will use that. So let's take a look at some examples. Example 1, a sports analyst feels that a tennis star has a 25% chance of winning a tournament. If this is true, what are the odds in favor of winning the tournament? Well, I guess the event is winning the tournament. That's event A. And if you think of it, the probability of winning is 25%. That means the probability of losing is 75%. And based on what we understand about odds, it's just simply the ratio of those two numbers, which simply can be written as a fraction, 1/4, 3/4. PA over PA prime is 1/4 divided by 3/4. And of course, the 4's cancel, and you end up with 1 to 3 odds, or 1 over 3 if you left it as a fraction, but it means the same thing. Example 2, Michael's sock drawer has 3 red socks with 5 white socks and 4 black socks. What are the odds in favor of Michael randomly drawing his red sock from the drawer? Again, event A is picking a red sock, so he's got 12 socks in the drawer. And what's the probability of picking 3 of them? Well, that makes 3 over 12, right? And the probability of not picking a red sock would be picking either a white sock or a blue sock, which would be 9 out of 12. So the ratio of 3 over 12 divided by 9 over 12 is the probability of A over probability of A prime, which again is 1 to 3 odds, because the 12's cancel and you're left with 3 over 9, which is 1/3. Let's try a couple more. If the chance of a snowstorm in Burlington is estimated at 0.35, now this probability is given as a decimal, so just keep that in mind. Sometimes we can write it as a percent, sometimes they can write it as a decimal, but as you're familiar with, percentages can be written as decimals. That really implies the odds against Burlington having a snowstorm. So the event of not having a snowstorm really means it's probably 0.65. Because when you're thinking about a percentage, it would be 35% plus 65% gives us 100. As a decimal, it would be 0.35 plus 0.65 is equal to 1. And of course, we've labeled the event A as snowstorm and the event A prime as no snowstorm. And we know that the probability of no snowstorm is 1 minus the probability of getting a snowstorm in decimal form, as I just explained. Probability of A prime over probability of A, because we're trying to find the odds against, is 0.65 divided by 0.35. But wait a minute, when you calculate this, you get this ugly decimal place. And no one gives you odds in terms of decimals like this. We prefer them in fractions, so we have to go back and start looking at the actual numbers that we're dividing and see if we can try to come up with a reasonable fraction in terms of whole numbers. Well, if you think about it in terms of factoring this, if you think of what two numbers multiply together to give you 65 and what two numbers multiply to give you 35 in terms of common factors, you'll find that 5 is a common factor between them. So 13 times 5 and 7 times 5 gives you the numbers 65 and 35. I've written it as a percent just so it's not confusing with the decimals. I just wanted to keep it clear that all I'm looking at is the numbers, really. 13 times 5, 7 times 5, that really means 5's canceling, left with 13-7 odds against snow. Example 4. The odds in favor of event A occurring are 10-7. So now you're given the odds. Now you're trying to find the probability. You're almost like working the question out in reverse. So remember our equation that we have. Well, the probability of A prime is 10/7, which is given. That is also can be represented by h/k, h being 10 and k being 7. If we substitute it into our equation that we looked at in the first slide, you see the probability, or second slide, the probability of A is equal to h/h plus k, which is 10/10 plus 7, which is 0.59, or 59%. You can think of it this way, if you have 17 trials, 10 of them will be this event A occurring, and 7 of them will be the event not occurring, and the total number of times would have been 17.